Hello and I welcome you to my video classes on concrete technology, and in this video we are mainly discussing about continuation part of high performance concrete. So in previous video we studied what you mean by high performance concrete and which are the materials used for high performance concrete and behavior in a fresh conditions, behavior of the concrete in a hardened conditions, right? So here in this video we are going for continuation part of high performance concrete, and it is video 2, right? And myself Vishwanath Avati, and mainly we are discussing in this video few advantages and a few limitations and some applications in the civil engineering field, right? So now we'll go for advantages. So advantages with comparatively normal concrete. So how on high performance concrete has a good advantages over a normal concrete, and many advantages are there. Here we are taken only few advantages and we will study one by one, right? So first one is reduction in the size of the column. If you see the normal concrete, right, and because of the less durability and because of less strength and performance, it may taken the bigger size. So because of the good strength and durability, even we can make the less size of the column with the same stability or how much is required to carry the load. Same also you can carry the load with a smaller size because of the characteristics of high performance concrete. Next is speed of the construction. So speed of the construction, why it is? Because it is workability is good and flowing ability, filling ability, and even segregation is very less. So that's what, because of the good condition, and even it has a fluidity is very good. So due to this it has a less hurdles, and because of less hurdles, and it makes the faster construction activities. It reduces the time comparatively. So then more economical than steel concrete composite columns. So here you have to understand first what you mean by steel concrete composite columns. So here two materials are used to prepare the columns. So we know what you mean by column. Column is what? It is a vertical member of the building which carries the load, right? Dead load as well as live load. But here it is made up of both materials. Both materials means what? It is made up of with concrete as well as steel. That's what it is called as a composite column. So more economical than steel concrete composite column. Next, workability and high pumping ability. We know what you mean by workability of the fresh concrete, right? It should be, yeah, flow in a good flow is required very in a good condition. Filling ability is also required in a good conditions. Even it to flow without segregation, right? So then you can call it as a good workable with the required slump values, right? So here if we comparatively high performance concrete has a good workability as well as high pumping ability. So why we are using a high pumping ability here? Because even concrete is pumped, like even you can see here it is in a pumping machine. So here some instruments will be there, and if you go for high rise building constructions, so here we required pumping of concrete like a pumping of water. So how water is pumping from ground level to where it is required. So similarly concrete is pumped same way, but instruments are different, right? Maybe it is the RMC concrete, and from that there will be a separate pumping instrument, from that it will pump. But here all the concrete are not good for pumping. If we take the high performance concrete has a good ability of pumping up to 50 floor also, after it will go more than 50 floors. So next, most economical material in terms of time and money. So here time is also good with respect to time and money. Time and money. So should not come separate. We should not understand it with separately. Money is also important as well as time is also important. If you take the both consideration of time and money, high performance concrete has a very effective method and cost effective of the constructions. Next is increased rentable or useful floor space, because of, as I told, because of small sizes of the structures, right? And workability is good, even we can make the good aesthetic appearance, as well as we can make good utilization of the how much space is available on the floor. So even we can use very effectively available space of the building. High seismic resistance, very important requirement of the building is it should has a good resistance for earthquake collapsing of building, because some building will may failure because of the high earthquake forces. You can take the example of Japan, right? In Japan, it will get frequent earthquakes, so their buildings will be constructed with a high seismic resistance, right? And here high seismic resistance means what? Seismic waves will be generated during the earthquake, and that waves may cause the failure of the building. So here, if you take the high performance concrete, it has a good resistance for seismic vibrations or seismic disturbance, and it reduces the failure of the building due to seismic failure. Next is wearing and abrasion resistance. It has a good wearing and abrasion. Abrasion means what? Removing up, like no, cutting up, like no, it is if you see some like no stone, when you see the stone, some part of the stone will be like no cut, or it may be it cutted. Why? Because it has a abrasion or friction between two materials, right? Similarly here also, if you take the wind blow, or you take some flood situations, if for example if you're constructing the bridge, so while constructing the column of the bridge, it may get the high velocity waters. So due to high velocity water and sand, it may cause the wearing and tearing of the column of the bridge. So here if you use the high performance concrete, it has a high wearing and abrasion resistance. So it is good for hydraulic structures as well as high rise building to resist against the high wind blow. Right, it has a good wearing resistance and abrasion resistance. Next is durability against the chloride attack. So we know what you mean by chloride attack. It is one of the chemical attacks, right? So in the concrete, in it may be in hardened concrete, and it may causes the like no some damages inside the reinforcement. It may cause corrosion of the reinforcement. So here, if you use high performance concrete, it has a good resistance for chloride attack and durability against the chloride attack. Increased durability in a marine environment. So if you use this concrete in a marine condition also, marine condition means what? In a sea condition, or if you see the saltwater condition, when we are using in a sea, even it has a good durability in a sea. It is what? Under the underwater construction, mainly it is related to underwater construction. Low shrinkage and high tensile strength. Low shrinkage, it is one of the like no strength parameters. It has a low shrinkage, means damages. It has a good low shrinkage means good durability, as well as high tensile strength. So we know tensile strength is comparatively low for concrete, but if you take the composite of reinforcement and concrete, comparatively with the normal concrete, it has a high tensile strength. Next, service life more than 100 years. As I told, if you take the comparison between normal concrete and high performance concrete is, even initial cost of the high performance concrete is high, but if you take the long term, maintenance is less, and even it will give the good condition in up to long term up to 100 years, more than 100 year also. Reduced maintenance cost. It has a reduced maintenance cost. Next, limitations. So some limitations are there, and it all depends on the property and the other different materials, but in generally some few limitations are there, and mainly limitation is related to expertise in a selection of material, preparation of material, placing of the concrete, and other things. Mainly attention is required, more attention is required, and more care is required while preparing and while placing the concrete. So we'll see one by one. First one is high performance concrete has been manufactured and placed much more carefully than the normal concrete. So here it is, as I told, while preparing the concrete and while placing the concrete, we have to take more careful. If you not take the careful, then entire purpose of the use of high performance concrete may failure. So that's what, if you want to get a good strength, then we have to take more care while preparing as well as while placing the concrete. An extended quality control is required. Extended quality control is required. Extended quality control is required means what? Frequent tests we have to make and to know the strength, and if it is not getting the strength, then we have to check why there is a failure of getting the strength. So that's what quality control is required more comparatively normal concrete. In concrete plant and at a delivery site. See here it is a concrete plant, maybe RMC, ready made mixed concrete, and at a delivery site where construction is taking place. Additional tests are required. Additional tests are required even in preparation of the concrete. In where actually concrete is preparing, there also testing is required, as well as where we are making the placing of concrete. Even in site also we have to make the testing of material, maybe it is a slump test, right, in a fresh condition, and even preparing the cubes, cylinders, beams to test the different requirements, even test as well as preparation or manufacturing of place. Next, some special constitutes are required which may not be available in the ready mixed concrete plant. So maybe some different materials are required time to time. If it is not available, then it makes the some of the drawback, or it makes the some problem. So some constitutes may not be available in a RMC plant. Initial cost is high than normal concrete. That I told. Initial cost. Initial cost means manufacturing cost, placing cost. It is high, but comparatively longer duration is effective. But initial cost is very high. Even it is one of the limitation. Next is skilled workforce is required. As I told, it is if you see the limitation 1, 2, 3. Full expertise is required. Selection of the material is very important, and placing of the concrete is also very important. For normal laborers, it is not possible. So that's what skilled workforce is required comparatively with the normal concrete. Next is some of the applications, right? Almost in most of the places they are using high performance concrete, right? High strength and superior durability. So why? Because high strength and superior durability characteristics of high performance concrete have already utilized in many structural applications. Many structural applications, not only few which are from categorized or which are noted here, but even other places also they are using in various countries. Some of the following high performance concrete are, some of the applications are some, right. So here we are, high performance concrete are used for pavement constructions, road constructions, and maybe and road constructions mainly they are using high performance concrete because of the good strength. Next, long span bridges. So next, first one is main preference is pavement, and in the pavement again in a long span bridges you can see some of the metro bridges are very which required very long support, and because of some requirement, so even for long span bridges they are using high performance concrete. Then high riser buildings. High riser, you can see here it is high riser building because of good workability and pumping ability, and early it will get early good strength comparatively. So that's what they are using for high riser buildings also. Next, in pre-stressed concrete. So, for example, prefabricated. For example, if you take any beams, right? Even beam can be created on the site also. Even the beam will be manufactured at the manufacturing unit, and it's transported. Even at the site also, free costing will be made. So that is what pre-stressed concrete. In the pre-stressed concrete, high performance concrete is used. Mainly it is a prefabricated concrete. High performance concrete is giving the good result. Hydraulic structures. Next is hydraulic structures for construction of power plant, hydropower plant, or spillways. You can see here these are the spillways, and mainly they are using for hydraulic structures where high pressure of water will be released and high pressure of water will be stored, and even hydro power plant. Next is tunnel lining. You can see here it is a tunnel, but at the surface we have to make the tunnel lining, right, to get a good surface, and even it has some supporting material. But this is tunnel lining will be done with high performance concrete. Next, power plants. As I told, hydraulic structure. In the hydraulic structure, even we are using hydro power plant. But if you see some other power plants like thermal power plant and nuclear power plant, so even in nuclear power plant and thermal power plant, high performance concretes are using. So these are the references taken for to prepare this slide, and for more information you can go and you can get the more resource in these two websites, right, for related to high performance concrete. So thank you so much for watching my video.